Welcome back, everyone. So we're actually getting pretty close to the final stages of this fan restoration, and we're only like 3 or 4 days into it. Believe me, I've been working on this thing every day since I acquired it. What we have here is the head badge. In our last video, I painted it green. Yuck. It's not supposed to be green, it's supposed to be brass. Well, originally, it was, in fact, painted green, and then they had lightly sanded away the green on the raised surfaces, and that is how you get that brass printed look with a green embossed background. It's pretty cool. So how I'm going to do this is I'm going to put some sandpaper down, and let's see what I got for sandpaper. I've got a sheet of 1500 grit, 320, and 180. I'm going to shoot for some 320, follow it up by some 180 to kind of give it a little polished. I'm sorry, 320 followed by 1500. This way we get a little bit of a polished look. I've got my scissors. Cut out a square of 1500. And I'm going to glue it down. I'm going to use some Super 77. Apply to our board. We're going to let that kind of cure. So I'm going to grab my freshly painted emblem, and I'm going to ruin my new paint job. Oh my god. I'm going to start slow. We're starting to get the effect there. A little more. What I'm doing is I'm actually slowly rocking it around the edges like this. So that we get, so see how it does one of these? We're kind of slowly rocking it so that we capture all the edges. We're getting there. We're getting there. We may have to do some of it by hand. That's okay. There's a low spot here. We're going to have to take care of that manually by hand. That's okay. Sandpaper might be coming loose. I think this one was a little bit damaged, and that's why we're not getting it. We might have to do some of this the hard way, but that's all right. So to get some of the finer points, you can always take a small screwdriver or blade and just carefully remove some of the stubborn paint with that. So unfortunately, avoiding some of those raised peaks is not as straightforward as I'd like it to be. So I'm at a point right now where I'm pretty satisfied with the results, and I'm going to just go ahead and clear it with clear lacquer. But the first one I did, it was on a 12-inch model, and it was a little more domed than this one is. This is a little bit flatter. It's also a little bit bent in a few spots. So we're going to just clear it. And what this is going to do is prevent it from ever discoloring, which is what I want. I don't want it to discolor. And we'll just let that dry. And when the cage is done, we'll mount it on the cage, and that'll be it. Okay, so the cage just came out of the Evapor-Rust tank, and look at that. This looks brand new. Absolutely brand new. I'm gonna cook it a little bit with my heat gun. I just washed it with soap and water, and I want to heat it up so I can get these wires good and dry so that they can take paint. I want to get paint on this as soon as I can because I don't want it to flash rust, because it will rust. I want to paint this outdoors because we're painting wire. That means a lot of overspray, a lot of paint will just get everywhere, and I don't really want that in my house. So we're going to do this outside. There's adequate ventilation. Let's see how we did. So I did this outdoors, and I'm going to have to touch up this part here where the suspension wire was. But it looks like I got pretty good coverage on all the wires equally, and I think it's going to be just fine once that cures. Now this one can of acrylic quick was enough to do 3 coats on the entire motor housing, the base, fan blade shroud. So, I mean, if that gives you a little idea as to how much paint you should buy, I would probably do maybe 2 cans. I bought 2 cans, and I think that's how much you're going to need. So if you're going to do one of these, get 2 cans of paint at a minimum. And these blades, you know, they came out the way they came out. They're heavily damaged. I wasn't expecting that when I started this project, but it is what it is. So I wanted to take the switch plate completely apart and then polish each piece individually. Unfortunately, that was not going to happen. It looks like the factory had peened over the threads on some of the parts on the switch plate to prevent them from coming completely loose. So I'm just going to take my buffing wheel. I mounted it on my 1936 Delta DP220 drill press, and we are just polishing what we can. What we can't polish, we'll just clean up with some deoxit and some electrical switch and tuner lubricant. That came out pretty good. I think that was It's important to note, though, the part of the switch that might be visible from the fan when it's assembled, I cannot access because I cannot get the screw out that mounts the switch to the plate. So. Alright, so what I wanted to do was kind of clean up the switch plate and test the coil, make sure all's good there. We don't want any surprises during reassembly. So, we're going to check the coil has basically a common and two taps. And we're going to go for, this is the common right here. And we're going to measure between this point and this point. We have 6.1 ohms. And from this point to this point, we should have a little bit higher resistance. It's 7 ohms. There's about a 1 ohm resistance between them. So that's good to know. So the coil's not open circuited and it's not shorted. Now the way the switch plate works, you have the head wire goes here. Doesn't matter. This isn't polarized. So one wire goes from here to the head, to the coil, the stator. And then you've got the other wire from the stator going down to this connection point. Power coming into the wall. You have one leg on this side, one leg on this side. And what it's going to do is when it's on its highest setting, it's sending full power directly. It's not going through the coil at all. It's sending full power directly to the stator on this end. When it's in the medium position, power is flowing from the stator through the coil from this point out to this point, and that gives you like a 1 ohm drop. And then from this point you get a 2 ohm drop. from full stop. So makes sense. We'll go over some wiring later on in the video, but for now I've got to clean up some hardware that I removed. I took this bar off. I'm going to just clean it up with my wire wheel, and I'm going to reattach it. This is the bar that keeps the switch in position. Fortunately, we lucked out. We actually have one that still has its original switch cover. Now this is a fun little bedtime story. See, this is what makes these so freaking dangerous. Other than the blades, and I mentioned this in an older video I made about the first AOU fan I had, but if this cover falls off, this is live. This could be hot, it could be neutral. Russian roulette, my friends. Depending on how your house is wired. These didn't have polarized plugs. If you want to be safe, what you've got to do with one of these old fans is you've got to put a polarized plug on it and make sure that this is on your neutral side. Because if it's not, well, even if it isn't, even if it is, it doesn't matter. You're still going to get shocked. So just have at it. Just if this cover falls off, this fan becomes unusable. Okay, so now we're going to be wiring our stator, and what I'm going to do is I'm going to leave our cord full length. I mistakenly cut a foot off thinking I only needed a foot, but sure thing. Alright, so we're going to start by getting some protection on our cable. Now I need a cigarette lighter. Okay, this is not rayon. This is cotton. Well, I guess that's cotton. Well, fortunately, the other end is already taped off, so I can just slide this over it. All right. You can't go the other way with this because what happens is it's going to unravel. So we're going to leave enough for, we're going to do that much right there. And when we slide this in, get this out of my way. When we slide this guy into the stator this way, the extra layer of protection, shrink tube, is going to protect it from chafing. And then we're going to just split it off into 2 wires, and then we're going to wire it from there. Our heat gun. And we're just going to shrink it. I'm going to get my soldering iron heated up and prepared, but this is going to slide in through here. You see how the shrink tubing protects the wire? Okay. But before I do that, I want to run the wire through my grommet like this. So I've already gone ahead and I put a grommet on our motor housing. And I'm gonna have to cut this rayon or this cotton out of the way so it doesn't get all tangled up. We want to get that through the housing, and we're gonna route it through the stator. I'm using a roll of tape as my work surface and this nice thick drying towel to protect the paint. Try to zoom in a little bit so you can see what I'm doing here. So we're going to run this through here, and we're going to split off our wires. Polarity doesn't matter. This is a simple, well, not just polarity, but in general, none of this matters because the motor that we're working on, it's just a single coil shaded pole stator. So Okay, so that's that. So let me get my soldering iron all set up. All right, let's see how bad this looks. Now the wiring coming out of the stator is clearly just hammered. You can see there's a single strand of wire right here. We want to keep that intact. That is necessary. We need to use that. We can't lose that single strand. If we do, we're going to have to maybe rewind the whole thing. Now, given the fact that this wire is in such that the insulation is crap, I can just crumble the insulation right off. And I can see the original solder joint right here. I'm going to do the same thing to the other side. We're just going to cut this piece off here. Look at that. Look at that. Oh boy. Oh my. So, if we break this wire off, we're going to have to go digging in the coil to get more wire. So, we don't want that to happen. Let's blow that away. Yeah, we don't want that to happen. So, what I'm going to try to do, I'm going to try to heat this up so I can melt this existing solder. We don't want to pull it off. We just want to unwind it a little bit. But the more we work it, the more likely it'll break. So you're kind of just trying to make ends meet without breaking. You know, I think what we can do, we have enough wire here to work with, so I'm going to just go ahead and cut my losses right about here. Maybe we can peel some of this off and then just cut it right about there. That's going to give us enough wire to work with on that side. Now for this one, so I'm going to just snip it there. We're going to get some sandpaper, and we're just going to sand any existing enamel off the wire, like so. And we're going to do this side here. I mean, people have these coils rewound all the time. I mean, it's something that can be done. If there's a short or any other damage in the coil, you can have them rewound. It's also not a bad idea while we're here to just check it for resistance. Like we did with our switch, we want to check the coil, make sure it's not shorted out. Otherwise, we're wasting our freaking time. All right. It is not shorted. It is not open either, so that's what we want. We have 360 ohms, kiloohms, so I imagine that's fine. I haven't looked up what the readings should be, but all right. Now this is critical. We want to make sure we get some shrink tubing on this guy first. So I'm going to do that now. They did not have shrink tubing in the 1920s. Yeah, I know, right? 1920s. This thing's old. But yeah, they didn't have shrink tubing back in those days, but we do now, and it allows us to build a much safer connection. We have better things now. Imagine that. Some things are better, some things are worse. Well, it depends on how you look at it. All right. So I'm going to wrap this guy around like this. nice and tight. And I'm going to do the same over here. Now while I'm soldering, I'm going to use a pair of, I'm going to use my needle nose pliers to act as a heat barrier for the shrink tubing so that it doesn't let go or it doesn't start shrinking. I'm going to clean our tip. I'm going to get it nice and toasty. There we go. Okay. All right. That's good. I'm just going to trim the end of this off. I don't want it to be sharp, you know. If it's sharp, it'll cut right through the shrink tubing, which would suck. Fold it over, and then run the shrink tubing up to the connector, or to the connection, and encapsulate it completely. Okay. Okay, it doesn't want to cover it. I'll make it. I will force it to do so. There we go. Okay, there's one. Now we'll do the other one. Pull this back as far as we can. Let's just see how this goes. Try to give it a... I don't want any loose. Come on. A pair of side cutters here. There we go. Good connection right there. We fold it back. And then run the shrink tubing as far as we can, as closest to the stator as we possibly can. I'm going to pull this back a bit. And look at that. Take our heat gun. And unplug the soldering iron. Always remember to unplug your soldering iron, guys. I can't tell you how many times I've done that. Okay. Okay, so our stator wiring is done. We've got our cabling going through the motor housing. Let me refocus you guys. A couple of things I've done to prepare for this. I have already gone ahead and make sure we have it. Yeah, we have a stop on that. Put my grommets in. I've coated the inside of the motor housing in WD-40, and I've cleaned up with a wire wheel the contact points. You have to make sure that it goes in completely straight. Skewers actually work pretty well for that. Let's go get some. Let's try these. Damn it. They're too thick. So what we gotta do is get them to line up with the holes. Yeah, I could probably do that. Just freeze the coil to get it to shrink. That is one possibility. Yeah, it just wants to go in cockeyed. Oh, there we go. There we go. Oh! Ha! Okay. Well, that happened. Did it bottom out, though? That is the question. Let's see if I can see the... well, we can always tap it in a little more. You know? Well, that happened. I think that's it. I think it's bottomed out. And if it's not, once you get the screws in, it'll self-align, or it'll reach its point of, so the wiring looks good. Okay, good. Of course, why would they line up, you know? Why would they line up? See how far off we are. No, we're lined up. So that's that. We are lined up, my friends. All right, so we got the wiring in, we got the screws in, stator's in place. We're getting ready to put the gearbox back on, put the motor shaft, all that back in. I just want to see how this fits. See if it's going to be a tight fit or not. I think it'll be fine. We're going to set it up with, we're going to find the stator. I'm sorry, the rotor. Oh, here it is. And we're just going to drop a couple new washers on this guy. And, probably put maybe a couple, 3, 4, maybe 2 or 3 thrust washers. What do you guys think? How many do you think it's going to need? 'Cause I don't know, but I've been told. No, that's not the right size. It's going to be these guys here. Yeah, those are the size we need. I'm going to put maybe, what do you think, 2 or 3? I'll have to see how it runs. I'll put 2 per side. That should be all it needs. Put some pre-assembly, a little bit of oil down in there. So what we'll do is we'll lubricate the shaft. A couple of drops in the bearing, just to pre-lube where possible. I'm gonna need more tape. Best idea I ever had to do it that way. I'm getting grease all over my new wire, so I'm gonna have to clean that after. Something. Grease is the word. Alright, we'll put that over there. Okay, so now we gotta reassemble our gearbox. So we're gonna shove this assembly aside. Grab our gearbox. Put down a couple towels. You gotta put it all back together again. I hope I can remember how it went together. Of course I know. So, recall, this goes in first. And I don't remember there being any washers on this side of it. Might have been one or two. Yeah, there should be at least one, maybe. Let's see what we got. So I do have all the bits and pieces here. Let's find one that's heavily worn. Yeah, like that one right there, maybe. And that puts it right in the middle. So there was definitely a spur gear that dropped down under this over here. And on top of that spur gear was a washer with a little notch in it. And that goes over here. Then you got the brass slug, and it had a little washer on the end of it, which might be this guy right here. Unless there's a smaller one. Does not appear to be the case. And the brass slug goes in. And you've got to send up the screw here. There we go. Tighten this screw down until it lands into one of the grooves in the slug. So we're going to use a flat blade on this end. So there we go. I think we found it. Okay, we're good. So we want to get it, I'm going to tighten it up. Where's my big one? No, that's too big. I guess this will have to do. You just want it snug and then get it nice and loose. You don't want really any play there. I think that's good enough. It spins freely. So we take this little screw and we just tighten it up. Not enough to cause metal damage, obviously, but that's how you do that. So we are now able to put this back on the motor. We've already got our preload washers, or I'm sorry, our thrust washers in place. We're going to need our stakes. Our alignment dowels. And, oh, yeah, that's right, the motor's cockeyed. So this is the bottom, the wire comes out the bottom. So this is how it lines up. Okay. And then we're going to do a quick blow to the back of the motor where it's lifting up here. I don't want to hit the paint directly, so I'm going to put a rag there. Take our alignment dowel out. Okay, it's now in place there. Take this one here. Okay. It's firmly seated all around. And how does the shaft look? Nice! It spins freely by hand. That's what you want. Now, what we're probably going to do is I want to light the motor up, and I want to find magnetic center, but actually I think this is fine, just the way it is. It's going to have a little bit of slack in it, and that's normal. Once it fires up, it's going to find its center, and it'll stay there. But that might be a little, maybe a little too much slack. What do you think? I think we should tighten it up. I'm thinking no. I'm thinking that's fine. I'm going to leave it alone right where it is. And we're just going to be happy with that and leave it the hell alone. So we're going to go ahead and pop in our screws for the motor back. Generally, I assemble the base first, but I decided to go backwards this time. I don't know why. I just wanted to get the motor together. That's the most anxiety-inducing part of this job, because the motor is where, you know, everything is going to go wrong. The base and the wiring is pretty much, you know, a non-issue. If we have to readjust this motor a little bit after we get it going, we can do that. You want to tighten these screws in a cross pattern. And then check to make sure the motor is still free running. Oh yeah, this is a good runner. What I did not do is I did not pre-oil anything on the back. So I'm going to do that now. We're just going to dump some oil on the back there. We're going to put some oil in the oiler over here. Just pump a little oil back in there before we forget to do so, because it could be our funeral if we don't. Okay. I'm going to fill the gearbox with some new red and tacky, and we're going to put the motor aside. We're going to take some photos for posterity. Get some shots of it, and we're going to get some red and tacky all up in that bitch. What I don't like is how if I push the motor back a little bit, it sticks. No, it doesn't. It's not doing that. But she wants to go. This thing is it's gonna go. All right, I got my Lucas red and tacky. Let's take a look at this. Ooh, looks pretty. I want to eat it. Red and tacky. All right, I gotta clean something or other. Take a gob full. Now, I've learned from other Fanamaniacs that you really don't want to fill the gearbox completely. You just want to get, I've heard 2/3 full is the number I've heard. But you just want to get it in there, that's all. That's all that matters. Try to work it down in there. I think that should be enough. That should be more than enough. Okay, wipe our hands clean. It looks like jam. Really want to eat this stuff. It It looks so delicious. Wouldn't you, though? I mean, really. We may be putting in another thrust washer in the back. I just have a feeling that we might have to do that. But we'll know a little bit more when we get it going. So, okay, the motor box, or the gearbox cover goes on next. Got that all prepped and ready to go. To apply that, you want to just screw this down. And see if that oscillator works. Oh yeah, that oscillator's turning. Nice. Okay, there's going to be 2 brass screws for that, which appear to be not in my box. Or no, maybe they're cap screws. They're not here. They are not here. Oh, here they are. These are not brass. They are not brass. So, I forgot about that. I don't know why they didn't use brass screws on that. Okay. I don't have them in another box somewhere. No. Nope, that's that. And these are the right ones. They fit. Okay, so we've got the back cover on. Look at this motor. This is so beautiful. It's my baby. It is so beautiful. Such a beautiful little motor. 98 years old. Just look at it. It's just gorgeous. Unbelievable. Don't forget, you want to put your oiler on, but we're not going to do that right now because the oiler is, well, it has to be full of oil, and I don't want to have to keep this motor upright the whole time, so I'm not going to do the oiler just yet. But we're going to put the brass data plate back on. Using the original rivets. See if it centers. Okay, data plate back is on. Data plate back is on. Anyway. Alright, I gotta find more grommets. I have a bag of grommets somewhere around here. I gotta go find them, and we gotta put grommets where the wires go through. But before we do that, we can start by reassembling the loop and stop and barrel. What about that? I did that. I was gonna say lock, stock, and barrel, but that makes no sense. I'm gonna put a little bit of my tacky grease inside the gooseneck, like so. Put a little bit of that in there. You don't need a lot, but you do want some. You just kind of stick it on there. Put that aside. Lock, stock, and barrel. Alright. That goes in here. Now we gotta find that pin and drop it in place. And that's right here. Gotta make sure we get it aligned. So I'm gonna put a screwdriver down in there. I think we got it. First try. So the pin's there, and that's supposed to prevent it from falling out. I got a couple of set screws, all different sizes. I think it's going to be this guy right here. Or that could be for something else. Yeah, that's for something else. Let's get that out of there. Okay. Let's see. Ah, it's this one. There we are. And there should be a key. It goes here. You know, it could go the other way around. I think the key goes on the top, or on the bottom, and the set screw goes on the top hole. Of course, they're threaded the same way, so an easy mistake to make. Yeah, I think that's about right. Okay, and that's supposed to stop it from swinging all willy-nilly. And the key goes here to lock it in position. I left these unpainted. I might paint them later on. I just nicked the paint job with my fingernail. That's alright. That's okay. Alright. Now I got this piece that goes here, and that's held in by this little. See, if you lose all the hardware for one of these fans, you're pretty much screwed. You can't buy this stuff anywhere. So I'm still missing one screw. Don't know when I'm gonna get it. Don't know if I'm gonna get it. I ended up paying the king's ransom for the missing, what screw was it? It was the fan, the blade guard screw. I paid a hefty fee for that sumbitch. I'm not happy about it, but I had to do what I had to do. I am not happy. Nor am I dopey or sneezy, but I am not happy. So now the next question is, okay, that goes there. This is the back. Okay, so chances are you could go either way with this one. I think it goes. I gotta look at the assembly drawings to see what I'm doing. No, I think it goes together this way. Apparently I had some stuff backwards. Actually, this goes like this. So the cables are in the back, and the oscillator arm is to the left if you're facing the rear of the fan. I had to double check. Not only that, but I was correct the first time as to the placement of this thumb screw, which goes at the top, not in the rear. And just like that. Actually, maybe I can pop this in because it's going to fall out. Maybe if I just set it right in there first. Let's see. That works out. We don't want to accidentally nick the paint anywheres. We can avoid it. There we go. Just believe me, making correcting paint defects after the fact isn't fun. We're gonna put a dab of grease down in here too. Wipe up the excess later. Snug, but it should freely move. And once you get it to that point where it's not vibrating or rattling around like it is now, then we can tighten down the set screw. These are lovely fans when they're done. We may have a little bit of bearing issues up here in the front. I'm noticing some up and down movement. You don't want to see that. It just means that the fan might make a little noise. But once we get her going, we'll know for sure. And we'll do what we have to. Okay, just snug that up a little bit. Yeah, that's in the bearing, unfortunately. So this motor might make a little noise. But again, she's 98 years old. Alright, so I got a couple of different grommets to choose from. Some big, some small. I've got these chunky mothers right here, which appear to be way too big for the hole. I got this guy here. No. Let's see what else we got. This one might do the job. Ultimately, nobody really makes a good replacement grommet for the AOU because, well, they don't make them anymore. You can't buy them at Walmart these days. So, let's see. I got a few different options to choose from. Let's see, what would be the most likely candidate? I'd say that guy right there. No. No, sir. No. That's too small. That's too big. But I think it's gonna work. Yeah, that'll work. We'll just pile drive our wire right through it. Let me get some silicone. So, pro tip of the day: when running wire through tight grommets, spray it with silicone. It's not going to hurt the wire. Most of it will end up evaporating anyway. But for the most part, it'll get your wire through in a pinch. So. Let's try to get the wire situated. It's going to take a little bit of mechanics wire, bend it into a U, slip it over the wire. I'm going to fold it over a couple of times like that, and we're just going to twist it together with a pair of needle nose pliers, which I have right here. This will prevent the wire from getting pulled out should it get caught on anything. And it's completely safe. So says I. So says I. There we go. Then we cut off the excess. With something stronger than these side cutters. There we go. And look at that. Just like they used to do it in the 1920s. And we'll pull the wire out a little more, like that. Look at that. Isn't that pretty? Like that. I like that. I think that works fantastic. Now we need a grommet for the wire going into the fan. The right thing to do might be to go back to the store, to the Lowe's. I think I got these from the one of those many antique fan parts suppliers that they have now, that they didn't have when I had my AOU back in 2018. Apparently these guys don't do a lot of AOUs. Well, anyway. I'm going to splay out the grommet so that it grips both sides of the casting rather than just one. That's a good fit. Actually, that was a good find. So we're going to leave about this much wire, maybe, to manipulate. Got it sharp. And the rest of the wire is our power cord. All right, far out. Just like that. And just stick them on. As if it were solid core wire. That's it. And probably put a washer in between if you want to, but like this. No crimping needed. Easy as pie. Now, we've got to have one leg from power mains going to here. So we're going to do the same thing here. Is this recommended by the FDA? Probably not. The correct solution would be to find yourself a set of brass terminal loops and do it that way. But, you know, sometimes I like to get creative. As long as nobody dies, it's okay. Toasty. But this is the kind of repair you might find in an antique appliance that may have been done by the owner, by a repair shop at some point. This kind of stuff you will find occasionally. Okay, so we need to pull this back a bit. Same thing here. Pull enough wire out of there to get the job done. There we are. Twisty, twisty. Smoky, smoky. Just like that. Unplug soldering iron because that's the last one we got to do. And I got to pull this terminal off, this nut. Switch goes over here, so that's got to be, oh, that's not long enough. That's alright, that's an easy fix. So we'll take ourselves a little knife, knifey knife, and we're just gonna go like that. We'll spread the chair. Play my cards right, I should be able to sneak this wire in there. What you don't want to do is get yourself in a situation where you can have a short circuit like that. Can't see what I just did there, but trust me, it would have been bad. Well, not deadly bad, but it would have been less than ideal. Look at that, good and tight. Okay. And then we just pull this wire back through. There we go. Actually, nothing touches. Nothing's shorting out. This is all in position. Nothing's... Oh, that grommet's fucking coming out there. There we go. There we are. Get the screws. What do you say we light the sucker and meet the old broads? But seriously, I do want to do one quick short check before we light it up, because the consequences of not checking our work first could be devastatingly bad. So in the off position, we should have an open circuit. I'm going to show the meter to you guys. Position number high. I think I overshot high. 9.6. Oh yeah, you got to factor in the motor. Medium. 11. And low should be a higher number than that. 12. Okay. I revert to my original phrase. We are going to light it up, baby. Here we go. It's off. Plug it in, plug it in. Here we go. Now, I've never seen this motor run before. I've never heard it run. I don't think I mentioned that. I have not heard this motor run yet because the wiring was so unsafe from the get-go. So I did all this work, and this motor could be a dud. Let's see. It runs medium and low. Okay. Gearbox makes a little noise, but that's not much I can do for that. Let's get some blades on it. Clear the prop. Clear prop. Here we go. Here we go. First run ever. Make sure this is locked so it can't swivel anywhere. Everything's good and tight. Here we go. And we're back after letting it run for a little bit, about an hour or so. Fairly confident that this is a good runner. So a couple of things. A little bit of oil has been dripping out of the oil cap cup, so I might have it maybe a tad bit overfilled. But not a lot of oil, really. I had to make a few adjustments to the blade, and I did that. I couldn't fit this on my drill press, so I couldn't use the same method that I used on my Vortilex to get the blade pitch and get it straightened out. So what I did is I took a piece of wood and I just marked off the distance from the leading edge and the trailing edge from each blade from a fixed point on the fan chassis on the loop handle part. And we got everything kind of straightened out a little bit. It runs a little smoother than it did when I first started it up. You'll notice I have this weird looking bolt just kind of hanging out right there. That's not permanent. It's just kind of tweaked in just to keep this strut from getting pulled into the fan. If that were to ever happen, it would just destroy the blades. I want to point out once again that this is one of the most dangerous fans I have ever owned, for one reason only. These blades, these 16-inch blades, are not protected whatsoever from little fingers and little paws. This thing will amputate a finger. I am fairly confident of that if you were to stick your finger in the back. If you stick your finger in the front, it'll more likely push your finger away if you're not too forceful with it. This particular style of fan is extremely dangerous. These blades are heavy. They are much heavier than the aluminum Vortilex blades, and they will break bone. Just gonna throw that out there, and it is fast. This thing runs real fast. I'm waiting for the last remaining. I have 3 of these strut screws that I've ordered. I think I mentioned it earlier in the video. It cost me a fortune, but I can't find them anywhere. So those are coming, and then I'll have that final strut firmly secured. But if this strut were to come loose, it would absolutely annihilate the blades. And possibly bend the shroud pretty badly. There's a lot of centrifugal force going in this sucker. So without further ado, let's fire it up. It's been run in a little bit, so it's going to run a little smoother, a little faster than it did on the first run. Here we go. Little vibration. It's not too bad though. Now if I hold this in position, not too bad. Not too bad at all. Now we'll go at medium. Again, there's a 1 ohm difference between high, medium, and low. So 1 ohm, so 2 ohm difference between low and high. So if you've got one of these, you can use my numbers that I found on both the motor, which I found was 300 kiloohms, and the speed coil, which was, I forget the readings, but if you watch the video, you'll see what I got for readings on that. So if you've got one of these and you're not sure if the coil or the motor is good, you can certainly use my readings as a reference, because this is a good runner. I think it's important to get those numbers out there so people can use them as reference points for fans they might be rebuilding or rehabbing. do a spin down. I'm going to have a 5-minute conversation during spin down. Here we go. So, total cost of restoration was, I would say conservatively, about $100 for all the work I've done and without my labor. So that's polishing materials, that's paint, that's sandpaper, that's grease, lubricants, everything, washers, wire, fan wick, what else? $25 is what it cost me for 3 strut screws. If you happen to need strut screws for one of these, let me know. I'm going to save 2. Oh, that didn't spin down as long as I thought it would. But anyway, I'm going to have 2 strut screws with washers, original ones that are going to be for sale if you need them. I paid a lot for those. I'd like to get some of that money back. I only need 1. The blade is still a little bit out of balance. I have no means of balancing it at this point in time. I just don't have what I need to do the job. And I think that a lot of that is because of all the buffing I had to do. You can see there's still a lot of scratching going on. I might actually take these blades off again and then sand them. Do a progressive sand, and I can get these going. I can get these looking pretty good. This one especially. This one's pretty bad, but these are all pretty bad. It's likely that somebody at some point used a wire brush to try to clean these blades, which was a mistake. Whoever did that, or whenever they did that, it caused some significant scoring on these blades. And it's a shame, too, because these are beautiful fans. It still looks good. I mean, it still looks beautiful objectively, but I know I can do better with those blades. And I might do that again in the future. And then maybe work on balancing them with an airplane prop balancer. That's what I found seems to work for people. Otherwise, everything went smoothly. There were no unexpected issues. Everything just went exactly as I hoped it would. The paint, I'm not as impressed with this particular paint product as I was with the Rust-Oleum lacquer. This is, again, acrylic wick by Krylon. And the finish just isn't what I was hoping for. Let me show you comparison-wise. A little bit of oil there. But you can see in some spots, and I went heavy on this stuff, which with lacquer, you have to really, it takes experience, and I'm new to lacquer, so I haven't really used it before, except for this one time, and when I did this fan, it actually came out looking absolutely gorgeous. But this is Rust-Oleum. This is not Krylon. It went on a little smoother, you know. But anyway, so overall, I'm satisfied with the results. I think that the choice of using gold wire, I think that was a good move on my part. Some of you might disagree. But that was my choice. You can do whatever you want. The factory colors, by the way, so it was a darker green than this. It was, I think somebody had mentioned it was like a Charlestown green, which you can't really buy anymore, I guess. And the factory wire color was olive green, and the factory base felt, I believe, was green as well. So this was all green and brass. We just did a little bit of a artistic liberty, or whatever the term is for that. We just did our own thing. So anyway, that's the result. So yeah, all in, I'm into this fan about $200. To give you some of what it cost me. I had to pay for the fan, which was $100, and I had to pay for all the materials to restore it. Now you factor in my time. If I were doing this to sell this fan, I would want to get significantly more than $200 for it. But that's just me. I won't be selling this fan. I'll be keeping this one. I regret selling the 12-incher that I did back in 2009 or 2008, because it was an absolutely gorgeous fan. It looked better than this one. Proportionally, I thought it looked better. Smaller blade, smaller cage, probably a little bit smaller base. It was a much stouter looking fan than this guy. But the 16-inch model is quite striking when you look at it. right up. You know, it's big. It's got a big blade, and it will chop your fingers off. No question, you will end up probably in the not the ER, but you might wind up at urgent care if you have an incident with this sucker, because it spins fast and there's a lot of momentum behind these blades. So just word of caution, you know, if you're looking to be cool and have one of these in your house and you have children, you might want to rethink that. Especially one of these stand fans, because this thing is low enough to where a kid could easily, but these blades are aluminum and they're not nearly as heavy, not as much momentum behind them. But they can still hurt pretty bad. They could probably at least send you into the urgent care for a flesh wound, whereas this sucker will break bone. And on that note, hope you guys enjoyed the video. And it looks like our cat is having a little fun. So, till then, folks, keep them spinning.